Light is that entity that helps us see. It bounces off of objects, lands in our eyes, on our retinas, exciting special cells that then send signals to our brain, which then interprets the signals to tell us what we see. However, we are told so many different versions of what light is. Is it a ray of energy? Is it a stream of photons, an electromagnetic wave, or something else entirely? What most students are taught in school about light is just one pixel amongst the HD image of light that we've painted so far. So, what in the world is light? The atom is made up of three smaller particles: the proton, neutron, and the electron. The proton and the electron carry electric charge. Many of you have heard that the electric charge is a part of the electromagnetic energy. This is because electricity and magnetism are actually manifestations of each other, and that deserves a whole video by itself. However, in this video, we will only consider the fact that an electric field that moves or changes over time creates a magnetic field, and similarly, a magnetic field that moves or changes over time ends up creating an electric field. Imagine having an electron which has its own electric field. Now, if the electron begins to oscillate, this causes a change in the electric field at a given point with respect to time. This creates a magnetic field with changes corresponding to the change in the electric field. As you would guess, this changing magnetic field causes another changing electric field, and the cycle continues, creating an oscillatory magnetic and electric field that propagates through space. This is the electromagnetic wave. This is what we call light. Now, electrons can actually oscillate at different frequencies, and this corresponds to different wavelengths. Based on these frequencies or wavelengths, we categorize the electromagnetic waves into different types. The shortest wavelengths form gamma rays, then comes the X-rays, then the ultraviolet rays, followed by visible light in the order violet, indigo, blue, green, yellow, orange, red, or VIBGYOR for short. Then we have longer wavelengths such as infrared waves, microwaves, radio waves, and long waves. This means that the light we see is only a small portion of the entire spectrum of different possible colors there potentially is for us to see. Now, these electromagnetic waves, due to the nature of quantum mechanics, can have only specific amounts of energy. So these electromagnetic waves travel in packets of energies called quanta, or photons in this case of electromagnetic waves. So these packets of electromagnetic waves are the particles of light that we call photons. Now, most of us would have heard the term wave-particle duality that is often associated with light. And with this much of the picture, most people would tend to think that it is because light is made up of particles of waves. However, this is not the case. Wave-particle duality comes from a quirk of quantum mechanics that allows tiny particles or quantum particles to be in multiple places at once when not being detected. Now, the multiple places that the particle can be present are determined by something called the Schrödinger wave equation, which can loosely be related to the de Broglie waves, which are associated with all particles. This means that the places that these particles can be present depend upon an imaginary entity that follow the equations of a wave. This is why the term wave-particle duality is associated with light. So, to summarize, when a charged particle oscillates, it creates a changing electric field, which creates a changing magnetic field, which continues the cycle forward, creating an electromagnetic wave that propagates through space itself, which we call light. However, due to quantum mechanics, we know that these electromagnetic waves are quantized and hence can only exist in distinct energy packets called quanta or photons, which are the particles of light. These photons can actually be present in many places at once, unless they are being observed, and the positions in which they can be and are most likely to appear when observed are determined by describing a wave function, and hence the term wave-particle duality was coined. Even though this video helped understanding light a bit better, like all good physics lessons, we should end with knowing that whatever was said is not the whole picture, and we've just started to get a 144 pixel visualization of what light is, and there is a lot more to know and to learn. With more advanced and more accurate theories such as the quantum field theory and string theory, the concept of photon particles and waves and the wave-matter duality seem to start blurring away as the techniques used to describe the universe change to explain more and more abnormalities that we experience in our experiments, in a hope to one day find out the true Ultra HD image of our universe. Thank you so much for making it through the video. If you have any questions, suggestions, or complaints, type them down in the comments and we'll respond to as many as possible. There is definitely a lot more coming up, so stay tuned, stay safe, and be ready to keep learning.